Hi, Assalamualaikum. So I'm Aminuddin bin Muhammad. So I'm going to present my dissertation one, titled Track Rectification Due to Misalignment and Ground Settlement for LRT3 Project. So my supervisor's name is Encik Muhammad Faiz bin Abdul Latif. This is my presentation outline. First, I'm going to present the chapter 1 of the introduction, chapter 2 literature review, Chapter 3 Research Methodology, Chapter 4 The Expected Findings, and the reference. So we start with Chapter 1 The Introduction. Degeneration of railway track would occur if it is constantly exposed to train traffic, or even worse, ground settlement happens underneath. This is cited from Zai et al. 2015. This research presents the rectification works on the track that is out of tolerance due to ground settlement after final as-built survey taken, which has exhibit some deviation from the design alignment. This study aims to identify the causes of misalignment and ground settlement and the rectification method proposed as a corrective measurement for the non-ballasted track. Next is the problem statement. In the railway track system, there are two types of track, which are ballasted and non-ballasted, that are also known as ballastless track. Slab track is made up of steel rail fasteners, and concrete mixtures. These components are very rigid when forming the railway track. It is very unlikely to be misaligned and settled after construction and during the operation. In LRT3 project, when the track work department has completed their construction of track, which is non-ballasted in Johan Steel Depot, the survey as-built rail alignment data shows deviation for vertical and horizontal of the track. The deviation that occurred on the constructed track are very significant and out of tolerance from the design alignment. Both deviation on vertical and horizontal alignment are influenced by the ground settlement that happened beneath the concrete slab that was previously constructed by the civil department in LRT3 project. The existing ground conditions underneath are influencing the concrete slab to settle. So the misalignment and the settlement of track can be caused by various factors in this case, such as high loading of slab track or instability of ground underneath. This is the illustration of example where in LRT3 project Johan Steel Depot, the deviation for horizontal alignment and vertical alignment can be seen even with the naked eye, where the horizontal alignment the rail can be seen, it goes sideways, and the vertical alignment is deviated vertically. So we move on to research objectives. First is to identify the cause of misalignment and settlement of the slab track by analyzing the conditions of ground underneath. Second is to analyze the effects of ground conditions towards the settlement of the track. The third one is to propose suitable rectification works to achieve design alignment of the track, including testing of the new related materials that is going to be used. And then the final one is to propose improvement to be made for preventing the track to be misaligned and settled in near future. These are my scope of research. First one, the scope will only be applicable to the study of non-ballasted track or slab track that are also known as ballastless track. And then this study also will only be applicable for a slab track that is constructed on the ground level. And the proposed rectification method is only applicable for a slab track type of railway or metro. So move on to literature review. First one, I picked the topic of non-ballasted track forms. Initially, sleepers were timber and the ballast was ash, but from the mid-1930s onwards, and as speeds and axle load increased, timber was slowly replaced by concrete and ash was by crushed stone. Alignment must be maintained in both vertical and horizontal directions, with track gauge and rail inclination in themselves becoming particularly important. This is cited from Bastin 2006. And this is the non-ballasted typical non-ballasted track formation where rail will be sitting on the slab, on the concrete slab, and the concrete slab will sit on the usually on the subgrade. Second topic on my literature review is on the railway track deformation. So railway tracks undergo plastic settlement when subject to repeated train loading. This occurs differentially along the track rather than in a uniform manner. This is cited from Charon Wong et al. 2020. Once differential settlement begins, track geometry can deteriorate rapidly because this further track settlement that caused by larger track dynamic interaction forces. I also take a literature review for ground settlement topic. So settlement refers to a movement of soil in vertical direction typically induced by changes of stress. The subgrade immediately bears the coupling effect of the self-weight loads, train moving loads, and environmental impacts as the support layer for the rails, leading to progressive accumulative settlement. So in the picture you can see the illustration of how the ground settlement can affect the track in a manner that directly affect the track. So the last topic that I chose for my literature review is the track maintenance, which is a little bit. So railway track maintenance and renewal are important for the safety of the railway, train punctuality, travel comfort, and cost effective. Move on to chapter 3, the research methodology. So the study will be conducted within Johann Steer Depot, or known as JSD, where the track settlement occurred on line 36, also known as test track, with the total length of 1.174 kilometers. The case study will involve data collection from LRT3 project, which is Shah Alam line, Bandar Utama to Johann Steer. The data from the construction department will be extracted for further analysis of the track settlement. The rectification work methods on the tracks will be proposed due to the misalignment of the track and ground settlement that occurred locally. This is the research methodology overview. So the stage 1 is the preliminary study, which involves the understanding of the ground settlement that causes the concrete slab to deform, and understand the deformation of concrete slab towards the track settlement. The stage 2 involving data analysis, analysis of track alignment data from track work department for better understanding of the track alignment deviation, and the comparison of track alignment data before and after the track has been casted. Stage 3 will involve the rectification method of the track itself, which proposing the suitable method as a corrective action, ensuring the track is within the design tolerances, and the comparison of rectification method that will be done. And the stage 4 is data interpretation. A conclusion will be made based on the rectification done, and the track alignment data will be compared before and after rectification is completed. So first, the ground settlement monitoring data will be extracted, will be taken from the civil departments to analyze the existing ground condition beneath the concrete slab that is causing the concrete slab to deform. Second one is track alignment data, which will be taken from the track work department. The data will involve the horizontal and vertical alignment of the track, and also it involves data before and after the construction. This is the typical track alignment cross-section of LRT3 project in Johann Steer Depot, where the track work data will be taken from this region, and then the civil data will be extracted from here, concrete slab and below, because this formation is constructed by the track works department, and the blue shaded region is constructed by civil department. So the track alignment data will be taken from track work department, where they are responsible for determining the correct positioning of track alignment geometry before and after construction of track plane. The data is recorded using the Trimble-Gaddo track system consists of the Trimble-Gaddo CE 2.0 track measurement trolley with a Trimble control unit in combination with a Trimble total station. The collected track alignment data shall be as follows. First is data before concrete plane is casted. Second one is after concrete plane is casted, and the as-built data, final alignment data. The research methodology involves the analysis of collected data. Data of realignment from Gaddo will be automatically generated from equipment and transferred to the computer. The data will show information such as drainage, outer geometry, can of the track, horizontal and vertical alignment of the track. All this data will be tabulated automatically by the equipment. The collected information then will be analyzed by comparing the data to determine how much the settlement has occurred and how it affects the track. The design tolerances will be taken into consideration to determine the value of the track vertical and horizontal alignment deviation. Comparison of rail alignment data will be made for pre-concreting and post-concreting of the concrete plane, or known as concrete slab. So the rectification methods will involve removal of running rail and track components. Second one will involve reinstallation of the running rail and track components, where coring and hacking will be done, realignment and realignment for correct positioning of the track, grouting of materials, and final alignment checking of the track itself. Material testing also will be done, which is the pull-out test. So the material used for rectification purposes shall be tested at an accredited laboratory or on-site testing to ensure the integrity of the new material. And the selection of material used also needs to be from a reputable brand. The expected findings of the study will benefit the contractors during the construction stage as well as railway system operators during maintenance stage by improving the track alignment according to design requirements. And the proposed rectification will help the track to be fit for the train to run and operate in Johan's Tier Depot. So this is the reference that has been used for my D1 report. Thank you.